Hello there, and welcome to the Sleepy Science Channel. Tonight, we're drifting into the deep ocean in search of one of the most elusive animals on Earth, the giant squid. For centuries, it lived somewhere between science and legend. Sailors told stories of enormous arms rising from the dark water. Naturalists collected strange beaks and bodies from lonely beaches. And far below the surface, beyond the reach of sunlight, the real creature moved through the blackness with eyes wider than dinner plates, arms lined with gripping suckers, and a life that still keeps many of its secrets hidden. This is an animal that belongs to the borderland between discovery and mystery. It is real, but rarely seen. Familiar in name, but almost alien in form. Every glimpse reminds us how much of the ocean remains unknown, and how many wonders may still be moving beneath the waves. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is relax. Let your body soften. Allow your breathing to slow. And as the day begins to drift away, join me as we explore the hidden world of the giant squid together. Let's begin. Giant squid can grow longer than a school bus. The size alone is enough to make this animal feel almost unreal. Much of that length comes from two astonishing feeding tentacles, which trail far beyond the body like living cables in the dark. The central body is not as massive as a whale or shark, yet the full outline can stretch through the water with a scale that feels legendary. Imagine meeting a creature whose arms could reach across a room before the rest of it arrived. That shape is part of what made giant squid so difficult to understand for centuries. When bodies washed ashore, their elastic tentacles could stretch even farther, turning real animals into even bigger stories. But the truth needs no exaggeration. A living giant squid is already one of the longest animals in the ocean, built like a deep-sea apparition, slender, powerful, and almost impossible to see coming. Their eyes are among the largest ever measured in nature. In the deep ocean, vision is not about bright scenery or colorful reefs. It is about catching the faintest disturbance before danger arrives. The eye of a giant squid can be wider than a dinner plate, which gives it a huge surface for gathering scarce light. Down in that dim world, even a tiny shimmer can matter. A moving predator may disturb glowing organisms as it passes, leaving a brief trail of light in the water. With eyes this large, the squid may detect that disturbance from farther away than many other animals could manage. This is not simply a strange feature. It may be a survival system shaped by one of the most intense predator relationships in the sea. Somewhere in the darkness, a sperm whale may be diving. A giant squid cannot outrun every threat, but enormous eyes may give it the warning it needs. Sperm whales carry giant squid scars like deep-sea battle records. Some of the most dramatic evidence for these encounters is written directly onto whale skin. When sperm whales dive into the depths, they hunt animals that humans almost never see alive. Giant squid can fight back with arms lined with suckers, and those suckers have hard tooth-like rings that can leave circular marks. On younger whales, the scars may look fresh and distinct. As a whale grows, older marks can stretch wider across the skin, becoming pale records of past struggles. These marks do not prove every detail of what happened, but they reveal something thrilling. Far beneath the waves, large predators and enormous squid meet in darkness, far from cameras and sunlight. The whale is the hunter, yet the squid is not helpless prey. Each scar hints at a hidden chase, a sudden grip, and a living struggle in a place we can barely reach. For centuries, sailors may have mistaken them for sea monsters, Long before marine biology had names for deep-ocean cephalopods, people told stories about monstrous arms rising from the sea. Some tales were fantasy, shaped by fear, weather, and long voyages across dangerous water. Yet behind certain legends, there may have been real encounters with giant squid. A dead specimen floating at the surface, a huge arm tangled in fishing gear, or a pale body washed onto a remote shore could easily become something larger in the telling. The famous kraken was not a scientific description, but it shows how the human imagination reacts when the ocean offers a glimpse of something enormous and unfamiliar. What makes this so fascinating is that the legend did not vanish when science arrived. Instead, science found an animal strange enough to explain why the legend felt possible. Reality, in this case, was still astonishing. Scientists filmed a wild adult giant squid only recently. For most of scientific history, this animal was known from remains, not living behavior. Researchers could study bodies from beaches, pieces from predators, and preserved specimens in museums, but the living creature stayed out of reach. Then deep-sea filming changed the story. Instead of dragging nets through the ocean and hoping for damaged evidence, researchers began using patient cameras, careful lighting, and lures designed for the world below. When a giant squid finally appeared on film in its natural habitat, it did not look like a clumsy monster. It moved with control. Its arms reached with purpose. Its body seemed perfectly suited to the dark space around it. That moment mattered because it shifted the animal from mythic object to living presence. A creature once reconstructed from fragments had arrived on screen, and it was even more fascinating than people had imagined. Giant squid live where sunlight fades into permanent twilight. Their home is not the bright blue ocean that most of us picture. It lies much deeper, where daylight weakens until colors drain away and the water becomes a vast, dim world. This zone is not empty. It is filled with drifting animals, flashes of bioluminescence, and predators that survive through patience and specialized senses. A giant squid belongs to this half-lit realm. Its body is soft enough for pressure, its eyes are built for faint signals, and its hunting style fits a place where surprise can decide everything. Human beings rarely enter that world directly. Machines go there slowly, lights disturb it, and every glimpse feels incomplete. This is why the animal remains so mysterious. It does not hide in some distant mythological sea. It lives on our own planet, in a layer of ocean that still feels almost alien. Their two feeding tentacles can shoot forward with astonishing reach. A giant squid has 8 arms and 2 longer tentacles, and those tentacles are among its most remarkable hunting tools. They can extend beyond the shorter arms and end in widened clubs, equipped for gripping prey. Instead of needing to bring its whole body close, the squid can strike from a distance. That reach may be crucial in deep water, where energy is precious and a missed chase can be costly. Picture a fish moving through darkness, guided by tiny cues it barely understands. Then, from outside its immediate awareness, 2 tentacles rush forward and close around it. The attack is not just about size. It is about sudden geometry, distance, timing, and surprise. This design allows the squid to turn a slender body into a much larger hunting radius, giving it a hidden advantage in a world where every movement matters. A giant squid's beak is strong enough to slice prey cleanly. At the center of all those arms is a mouth that looks strangely familiar because it resembles the beak of a parrot. It is hard, curved, and dark, and it does the work that soft arms cannot do alone. Once prey is pulled inward, The beak can cut through flesh with impressive force. This matters because a giant squid cannot swallow large animals whole in the way some predators can. Its food must be broken down into pieces that can pass safely through its body. The beak is also one of the best clues the animal leaves behind. Unlike soft tissues, it can survive inside the stomach of a sperm whale after the rest has disappeared. In this way, a small, hard mouthpart becomes a record keeper. It tells scientists what was eaten, how large it may have been, and how deep the hunt may have gone. Most giant squid discoveries begin with bodies washed ashore. There is something haunting about the way this animal often enters human knowledge. It does not usually arrive through a planned encounter. It appears after storms, strandings, or unusual currents bring a body into shallow water. People walking a beach may find an enormous shape, but looks partly familiar and partly impossible. Scientists then have to work quickly because soft deep-sea bodies change fast after death. Skin tears, tentacles stretch, tissue loses its natural form. Even so, these strandings have taught us a great deal. They have revealed anatomy, size, distribution, and clues about growth. Each one is a message delivered from a place we struggle to visit. The animal's life happened somewhere else, far below the waves. By the time it reaches shore, the mystery is already partly gone, but the evidence remains powerful enough to open another doorway into the deep. Almost everything we know comes from glimpses, fragments, and surprises. That is what makes the giant squid so different from many famous animals. Lions can be watched on plains. Eagles can be tracked in the sky. Even whales surface to breathe, giving researchers repeated chances to observe them. The giant squid offers no such easy access. Much of its story has been assembled from stranded bodies, predator stomachs, rare photographs, brief video encounters, and careful comparisons with related species. This makes the science feel almost detective-like. A beak suggests a meal. A scar suggests a struggle. A camera clip suggests a movement pattern. A preserved specimen reveals hidden anatomy. None of these clues tells the whole story alone, but together they build the outline of a remarkable life. The result is not ignorance. It is a frontier. We know enough to be amazed, and still little enough for the next discovery to change the picture. Giant squid belong to the mysterious genus called Architeuthis. This scientific name gathers the known giant squid into a group that still feels strangely unfinished. In many animals, a genus can be studied through living populations, repeated observations, and clear patterns across habitats. Here, the picture is harder to hold. Researchers have often had to compare specimens that arrived damaged, incomplete, or separated by enormous distances. A body from Japan, the beak from a whale, and a stranded animal from the Atlantic may all become pieces of the same puzzle. For a long time, scientists debated whether there were many different species or one widespread form with local variations. That uncertainty gives the name a special kind of power. It is not just a label in a textbook. It is a doorway into a scientific mystery, where even the classification of one of Earth's most famous sea creatures still carries shadows. The name Architeuthis means ruler squid in ancient Greek roots. There is something wonderfully fitting about that meaning. The word combines ideas of chief or ruler with squid, giving this animal a name that feels almost ceremonial. It was not chosen because the creature ruled the ocean in a literal sense. It was chosen because early scientists recognized that they were dealing with something extraordinary among cephalopods. The name carries the feeling of first discovery, when naturalists were trying to bring order to reports that sounded almost impossible. A huge squid was no longer just a sailor's tale or a beachside curiosity. It could be placed into the language of science, where every name becomes a small act of understanding. Yet the grandeur remains. Even today, Architeuthis sounds less like a simple category and more like a title given to an animal that still commands the imagination from far below the waves. Female giant squid are usually larger than the males. In many animals, size differences tell a story about survival and reproduction. Here, the larger sex is often the female, and that pattern may be tied to the demands of producing eggs in the deep sea. A bigger body can carry more reproductive investment, which matters when encounters between adults may be rare across such vast water. The male does not need to match that same scale to succeed. Instead, his biology is shaped around finding a mate and delivering sperm in an environment where darkness and distance make everything difficult. This difference also affects how specimens are interpreted. A particularly large, stranded animal is often assumed to be female, while smaller adults may represent males rather than young animals. What seems at first like a simple size fact opens a window into the hidden pressures of reproduction, chance meetings, and life in a world without easy landmarks. Their bodies are lighter than legends often make them seem. The old stories often imagined a massive monster with crushing bulk. Yet the real animal is built with a different kind of design. Its body is soft, flexible, and supported by water rather than heavy bones. This gives it a ghost-like quality. Enormous in outline, but not dense in the way a shark or whale might be. A giant squid is a creature of reach, movement, and sudden extension. Its strength is distributed through muscle and arm structure, not through armored weight. That lighter build is one reason dead specimens can look so changed when they reach the surface. Without the deep water around them, their tissues sag, tear, and lose the shape they held in life. The truth is more interesting than the legend. This is not a heavy sea beast. It is a long, soft hunter shaped for suspension in the depths. Most of their length comes from their arms and tentacles. When people hear the total length of a giant squid, they may imagine a body that is enormous from end to end. The reality is stranger. The mantle, head, and arms form only part of the animal's full span, while the two feeding tentacles extend far beyond the rest. This means its size is not like that of a long fish or a marine mammal. It is more like a central body carrying remarkable tools that can reach out into surrounding darkness. That shape affects how the animal hunts, how it is measured, and how it has been misunderstood. If a tentacle stretches after death, the reported size can become misleading. In life, though, the arrangement is beautifully functional. The squid does not need to move its whole body into danger. It can project part of itself outward, turning distance into an advantage. A giant squid's mantle is its muscular central body. The mantle is the main engine room of the animal. It holds many of the vital organs, and it forms the powerful wall that drives movement through the water. When the squid draws water inside this chamber and then forces it out, the mantle contracts with enough strength to create propulsion. It is also the part of the body that gives scientists some of their most useful measurements, because it is less misleading than stretched tentacles. In a fresh specimen, the mantle can reveal maturity, sex, and overall condition. It is easy to focus on the dramatic arms and enormous eyes, but the mantle is where much of the animal's hidden machinery is gathered. Think of it as a living pump, shelter, and muscle system all at once. It is the central structure that turns a strange outline into a working deep-sea body. Their fins help them steer through the dark water. At the rear of the mantle, two fins move with a different purpose from jet propulsion. They are not the main source of sudden speed. Instead, they help with balance, positioning, and controlled motion. In a world where light is scarce, precise movement can matter as much as power. A giant squid may need to hover, adjust its angle, or drift without wasting energy. The fins allow subtle corrections that a forceful jet alone could not provide. They make the animal less like a rocket and more like a careful swimmer when the moment calls for it. This matters during hunting, avoiding danger, or simply holding position in deep water currents. The fins are not the most famous feature, yet they show how refined the animal's design really is. Even a creature known for dramatic size depends on small adjustments to survive. Giant squid move by forcing water through a siphon. The siphon is one of the great inventions of cephalopod anatomy. It works like a flexible nozzle, channeling water out of the body after it has been drawn into the mantle cavity. By aiming that stream, the squid can control direction. The result is jet propulsion, but it is not a machine-like process. It is muscular, adjustable, and part of a larger movement system that includes fins and arm positioning. This method allows quick escape responses when danger comes close. It also helps the animal reposition in a habitat where there are no rocks, branches, or solid surfaces to push against. The open water is three-dimensional, and the siphon gives the squid a way to move through it on its own terms. It is one of the reasons cephalopods can seem so startlingly alive in motion, as if the whole body becomes a breathing engine. Their jet propulsion can launch them backward in sudden bursts. Because water is expelled in one direction, the squid can shoot the opposite way with surprising speed. This backward movement may seem unusual to us, but for a cephalopod it is natural. The head and arms often lead the animal's awareness, while the mantle provides the thrust behind the escape. In an emergency, there may be no time for a graceful turn. A sudden contraction can send the whole body away from danger, with arms trailing and fins adjusting the path. This ability is especially useful in the deep ocean, where threats can emerge from darkness with little warning. It also changes how we imagine the animal. A giant squid is not just drifting like a ribbon in the sea. It can accelerate in sharp bursts when needed, using its own body as a pressure-powered escape system. Softness, in this case, does not mean helplessness. Their arms carry rows of powerful toothed suckers. Each arm is equipped with gripping structures that are far more complex than simple suction cups. The suckers can fasten onto prey, while hard rings along their edges add a cutting grip. This creates a hold that is both sticky and abrasive. For an animal without claws or jaws at the end of each limb, that combination is crucial. The arms can gather, restrain, and guide struggling prey toward the mouth. They may also help during defensive encounters, leaving marks on attackers that come too close. The detail becomes even more impressive when you remember that these structures repeat along multiple arms, forming a living array of grasping points. A giant squid does not need hands in the human sense. Its arms are a surrounding capture system, capable of making contact from several directions at once and turning a brief touch into a firm hold. Each sucker can grip with both suction and tiny teeth. The power of a single sucker comes from more than a vacuum-like seal. Around its rim sits a ring of hard material with fine tooth-like edges. When pressed against another surface, the sucker can hold while the ring bites in just enough to resist slipping. Multiply that by many suckers along several arms, and the result is a formidable grip. This helps explain why marks from encounters can be so distinctive. The contact is not smooth. It can leave circular impressions that preserve the shape of the sucker itself. For prey, this means escape becomes harder the moment the arms close. For scientists, it means the body of another animal can sometimes carry evidence of a hidden meeting. Something as small as a sucker ring becomes a signature of deep-sea contact. It is a tiny structure, but it belongs to one of the ocean's most dramatic capture systems. Their tentacle clubs are shaped for snatching distant prey. The feeding tentacles end in expanded sections known as clubs, and these clubs are specialized for the final moment of capture. They carry concentrated suckers and gripping surfaces, which makes them different from the long stalks that deliver them forward. This design is almost like placing a catching hand at the end of a whip-like extension. The slender length provides reach, while the club provides contact and control. In deep water, that arrangement may allow the squid to strike without committing its whole body to the chase. A fish or smaller squid might pass within range, and the clubs can be sent out to seize it before it escapes into darkness. The beauty of the system is its economy. The animal does not need teeth everywhere or speed above all else. It uses shape, distance, and a specialized endpoint to turn a moment of opportunity into food. Giant squid likely hunt fish and other deep-sea squid. Their diet is known through stomach contents, beak studies, and comparisons with related predators. The menu appears to include animals that share the same dim layers of the ocean, especially fish and smaller squid. This makes sense for a hunter built to seize moving prey in open water. Deep-sea fish often have large eyes, reflective tissues, or glowing organs, and each feature may create a signal that can betray them. Other squid may be fast and alert, but they are also part of the same food web. The giant squid is not merely a monster waiting for whales. It is a participant in a layered ecosystem, hunting animals that are themselves adapted to darkness. Every meal connects it to a chain of life that begins with tiny organisms above or strange chemistry below. Its prey choices reveal an ocean where even giants depend on smaller lives. Their prey may never see the attack coming. In the deep sea, a predator does not always need a long chase. It may only need to remain unnoticed until the distance is right. A giant squid's shape, coloring, and stillness could help it blend into the surrounding gloom. If a potential meal is focused on its own signals, movements, or escape routes, danger may arrive from outside its narrow field of awareness. The strike can begin with reaching tentacles rather than a full-body rush. That gives the squid a way to attack from beyond the space its prey is closely monitoring. The darkness itself becomes part of the hunting strategy. There is no dramatic shadow, no warning splash, and no surface ripple. There may only be a sudden touch from the black water, followed by a tightening grip. In that moment, the giant squid turns invisibility into action and distance into surprise. Their long tentacles may strike faster than their bodies move. A large animal does not always need to move its whole body quickly. Sometimes the fastest part is the part that reaches. The feeding tentacles can extend toward prey with a suddenness that may outpace the motion of the mantle and head. This gives the squid a striking advantage. It can remain relatively stable while sending its capture tools forward, which reduces wasted effort and may preserve stealth. The movement is not just a stretch. It is a coordinated action that depends on muscle control, aim, and timing. The tentacles must reach the target, make contact with the clubs, and then pull the prey inward. In a habitat where food may be scattered, that efficiency matters. The animal's body may appear slow and drifting in one moment, then reveal astonishing speed in a narrow line of attack. The surprise lies in where the speed is hidden. Their beak sits hidden at the center of their arms. The mouth is not placed out front like the jaws of a fish. It waits where the arms converge, concealed until prey has already been drawn in. This arrangement makes the surrounding limbs part of the feeding process. First, they make contact. Then they control the victim's movement. Finally, they guide it toward the hard beak at the center. The placement is both strange and elegant. It turns the animal's arm crown into a living funnel, bringing food toward the one point that can cut it apart. For anyone seeing a giant squid for the first time, the eye may be drawn to length and motion. But the true danger for prey is hidden in the middle, almost tucked away. That central mouth is a reminder that the animal's body plan is not built around a face like ours. It is built around grasping, enclosing, and feeding. Giant squid use a radula to rasp food apart. Behind the beak lies another feeding tool that is easy to overlook. The radula is a ribbon-like structure covered with tiny teeth, and it works by scraping food into smaller pieces. Many mollusks have some version of this organ, from snails grazing on surfaces to cephalopods processing prey. In a giant squid, it helps turn captured animals into material that can be swallowed and digested. This detail matters because the beak alone does not complete the meal. It cuts and tears, while the radula continues the preparation with finer action. The system feels almost mechanical, but it is living tissue working with precision. A creature that seems legendary from the outside depends on a very old molluscan invention inside its mouth. That connection is wonderful. The giant of the deep shares a basic feeding heritage with much humbler animals, yet uses it in one of the most hidden hunting worlds on Earth. Their brain wraps around the tube that carries swallowed food. This is one of the strangest anatomical arrangements in the animal's body. The esophagus passes through the brain region, which means swallowed food must be reduced before it moves safely onward. It is a reminder that cephalopod intelligence evolved inside a body plan very different from ours. The nervous system is advanced, but it is organized around a mouth and throat arrangement inherited from molluscan ancestors. For the squid, this makes careful feeding essential. Large chunks could cause damage if they were not properly broken down first. The beak and radula are therefore not just useful tools. They protect the animal's own nervous system by preparing food before swallowing. It is hard to imagine a better example of biological trade-offs. Evolution does not design from scratch. It modifies what already exists, and sometimes the result is a brilliant hunter whose food passage threads through the center of its mind. Giant squid have blue blood based on copper-rich hemocyanin. Their blood is not built around iron-rich hemoglobin like ours. Instead, it uses hemocyanin, a copper-containing molecule that helps carry oxygen. When oxygenated, this blood can appear blue. That difference gives the animal a chemistry that feels almost alien, yet it is a practical solution used by many mollusks and arthropods. Hemocyanin works dissolved in the blood rather than packed inside red blood cells in the same way human hemoglobin is. For a cold marine animal, that arrangement can be useful, especially in conditions where oxygen handling has to match the demands of deep water. This detail changes the way we imagine the giant squid from the inside. It is not merely unusual in shape. Its very circulation follows a different biochemical path. Beneath the pale body and huge eyes, blue blood moves through tissues that belong to a lineage far older than humanity. Their blood works better than ours in cold ocean depths. Cold water changes the rules of survival. Chemical reactions slow, oxygen can behave differently, and an animal's circulation must keep working in conditions that would challenge warm-blooded bodies in other ways. Hemocyanin can be well suited to low temperatures and the oxygen demands of marine invertebrates. For a giant squid, this matters because its habitat is not only dark, but also cold. Every movement, every strike, and every escape depends on delivering oxygen to working muscles. The squid does not solve this problem by heating itself like a mammal. It solves it through deep evolutionary chemistry. Its blood is part of its environment, tuned to water where warmth is scarce and pressure is high. That makes the animal feel even more perfectly placed in its world. What would be hostile to us is not an obstacle in the same way to it. The cold is written into its biology. Giant squid breathe through feathery gills inside the mantle. Inside the main body chamber, water moves across delicate gill surfaces where oxygen is taken in and carbon dioxide is released. These gills are not lungs, and they do not breathe air. They work only because the animal lives surrounded by seawater, drawing that water inward and passing it over tissues built for exchange. The structure is wonderfully efficient for a soft-bodied creature in the deep. Each breath is part of the same internal flow that supports movement, because water entering the mantle can be used for both oxygen and propulsion. This means breathing and swimming are linked in a physical rhythm. The animal takes the sea into itself, extracts what it needs, and sends the water away again. It is a very different way of being alive from ours, yet it suits the dark ocean with remarkable elegance. Their hearts pump oxygen through a strange three-heart system. The circulation of a giant squid is not organized around a single central pump. Instead, it depends on three working hearts, each serving a particular part of the oxygen cycle. This arrangement may sound extravagant, but it makes sense for an active cephalopod with oxygen-rich demands and copper-based blood. Blood must be moved to the gills for oxygen pickup, then pushed onward through the rest of the body. Dividing the work helps keep flow moving through tissues that need energy for swimming, hunting, and sudden escape. It also reveals how different cephalopods are from the animals we see most often. They are not fish with arms, and they are not simple drifting creatures. Their internal systems are specialized, layered, and surprising. Behind the strange outer form is a working design that has been refined through millions of years of life in the sea. Two hearts send blood to the gills. These paired pumps are often called branchial hearts, and they sit near the gills where their job is direct and essential. They push oxygen-poor blood toward the breathing surfaces, making sure it reaches the place where exchange can happen. Without that extra boost, circulation through the gills would be less effective, especially for an animal that may need bursts of movement in cold, deep water. The beauty of the system is its division of labor. One heart does not have to handle everything alone. The branchial hearts focus on feeding the gills with blood, almost like two attendants serving the body's oxygen gateway. It is a reminder that the giant squid's strangeness is not only visible in its arms and eyes. Its internal architecture is just as remarkable, with hidden pumps working in paired rhythm far beneath the surface of the sea. A third heart pushes blood through the rest of the body. Once oxygen has been collected at the gills, the main systemic heart takes over. Its work is to send enriched blood outward, supplying muscles, organs, and nervous tissue. This is the heart that supports the animal's broader life, from controlled drifting to sudden movement. It does not work in isolation. It depends on the other two hearts to prepare the blood first, which makes the whole system feel almost like a relay. One stage gathers oxygen. The next delivers it where it is needed. Cephalopods are famous for their flexibility and intelligence, but that reputation rests on demanding biology. Muscles require fuel. Senses require support. Even stillness requires circulation. The third heart is therefore not just an anatomical oddity. It is the quiet force that keeps the whole animal supplied, allowing a deep-sea hunter to remain alert in a cold and demanding world. Their huge eyes help them detect faint, moving shadows. In the deep ocean, a shadow can be more important than a shape. The water contains scattered points of light from bioluminescent organisms, and any large moving body can interrupt or disturb that faint glow. A giant squid's enormous eyes are built to notice subtle changes across a wide, dim field. This kind of vision is not about admiring scenery. It is about reading the smallest sign that something has shifted nearby. A prey animal might pass below. A larger animal might move above. A change in brightness could mark opportunity or danger. With eyes of such scale, The squid can gather more light and detect weaker contrasts than smaller-eyed animals might manage. That ability turns the darkness into a readable space. The deep sea may look empty to us, but to a creature adapted for it, even a fading shadow may carry a message. Those eyes may reveal sperm whales before an attack. A hunting sperm whale does not need to glow for its presence to matter. As it moves through deep water, it can disturb tiny luminous creatures and create a shifting pattern of light around itself. The giant squid's unusually large eyes may be tuned to notice that disturbance before the whale arrives within striking distance. This possibility gives the eye size a dramatic purpose. It may not be mainly for spotting small prey nearby. It may be for detecting one of the most dangerous hunters in the ocean from farther away. Imagine living in darkness where the first warning of danger is not a sound you understand, but a faint, moving glow in the water around something huge. The squid's eyes become early warning instruments, built for survival in a place where a few extra seconds could mean the difference between escape and capture. Giant squid pupils can be surprisingly large and round. The pupil is the opening that lets light into the eye, and in this animal it can appear strikingly broad. That shape gives the eye a direct, almost startling look when specimens are seen up close. A large pupil matters because deep water offers so little light to work with. Every possible photon becomes valuable. The round opening helps admit what little illumination exists, while the rest of the eye's structure gathers and focuses it. This is one reason the animal's gaze can feel so haunting in preserved photographs. The eye seems less like a decoration and more like a deep-sea instrument. It belongs to a world where sight has been pushed toward sensitivity. In bright surface water, such an eye would be overwhelmed. Far below, it becomes a way to widen the narrow doorway between darkness and perception. Their vision is adapted for a world with almost no sunlight. Far below the surface, ordinary daylight is mostly gone. The environment is shaped by dim blue traces from above and flashes produced by living creatures. Vision in that setting has to prioritize sensitivity over sharp daytime detail. A giant squid's visual system is therefore suited to low light, broad detection, and movement across darkness. This does not mean the animal sees poorly. It means it sees differently from us. We are built for a bright world of edges, colors, and familiar distances. It is built for a suspended world where signals are scarce, brief, and easily missed. This adaptation changes the meaning of darkness. To human eyes, the deep sea can seem nearly blank. To the squid, it may be textured with faint cues, passing glimmers, and shadowed motion. Its vision is a translation system for a realm we are not designed to read. Giant squid probably see contrast more than colorful detail. Color becomes less useful as sunlight disappears because many wavelengths are absorbed before they reach the depths. In that environment, the difference between light and dark can matter more than a full palette of hues. The giant squid's eyes are likely tuned toward brightness, movement, and contrast rather than the rich color distinctions humans enjoy near the surface. This kind of sight would be perfect for finding silhouettes, flashes, and changes in the dim water around it. A fish does not need to be red or silver to be noticed. It only needs to interrupt the faint background in a detectable way. The idea is fascinating because it reminds us that vision is not one universal experience. Every animal sees the world its survival requires. For the giant squid, the ocean is not a colorful painting. It is a field of signals, shadows, and sudden changes. Their skin can change shade through tiny pigment cells. The surface of a squid is not fixed like painted fabric. It is alive with small structures that can expand or contract, changing the appearance of the skin. These pigment cells allow many cephalopods to shift shade with impressive speed, and giant squid appear to share some of that remarkable ability. The effect may be subtler in the deep than it is in bright reef animals, but it still matters. A change in tone could help the body match surrounding dimness, soften its outline, or respond to stress. In a freshly observed specimen, the skin can show reddish and purplish tones that hint at this living control. It is easy to think of a giant squid as pale and ghostly because many are seen after death. In life, its skin may have been far more dynamic, responding to the hidden moods and pressures of the deep. Chromatophores may help them signal or vanish into darkness. Chromatophores are pigment organs controlled by tiny muscles, and they are one of the marvels of cephalopod biology. In shallow water squid, they can produce rapid patterns used for camouflage, warning, courtship, or confusion. For giant squid, the exact role is harder to observe, but the possibility is captivating. In the dim ocean, even modest changes in shade could help break up the body's outline. They might also carry signals during rare encounters with another squid. A flash of darker tone, a spreading blush, or a change across the arms could have meaning in a world where sound and sight behave differently from the surface. We do not yet know the full language, if there is one. But the machinery is there, tucked into the skin. The animal may not simply move through darkness. It may write brief messages across its own body. Giant squid are relatives of octopuses, cuttlefish, and nautiluses. They all belong within the broader cephalopod group, a branch of mollusks famous for arms, complex behavior, and remarkable body plans. Yet the family resemblance can be surprising. An octopus crawls and explores with flexible arms. A cuttlefish hovers with rippling fins and dazzling skin displays. A nautilus carries a chambered shell and seems like a survivor from another age. The giant squid shares ancestry with them, but its own form has taken a different path into open, deep water. This connection helps us see it less as a monster and more as part of an extraordinary evolutionary family. Cephalopods have repeatedly solved problems with nervous systems, movement, camouflage, and predation in ways that look almost inventive. The giant squid is one grand expression of that heritage, stretched into a long, elusive shape suited to the deep ocean's vast interior. They are mollusks, like clams, snails, and oysters. At first, this relationship seems almost impossible. A clam sits inside a shell. A snail glides slowly across a surface. An oyster filters water from one place. Then there is the giant squid, long-armed, fast-moving, and armed with enormous sensory equipment. Yet, all belong to the same broader animal phylum. The connection lies deep in body history, not in obvious appearance. Mollusks can produce soft bodies, muscular structures, specialized feeding organs, and in many groups, shells or shell remnants. Cephalopods took that foundation and transformed it into something active and predatory. The result is one of evolution's great surprises. From the same ancient lineage that gave the world slow grazers and shell builders came a deep-sea hunter capable of inspiring legends. It is a reminder that evolution does not move in a single direction. It experiments wildly with the materials it inherits. Giant squid are among the largest invertebrates ever known. Most animals without backbones are small enough to hold in a hand, or at least small enough to overlook. This one breaks that expectation completely. It has no spine, no bony skeleton, and no rigid internal frame like a fish or mammal. Even so, it reaches lengths that place it among the giants of animal life. That contrast is part of its wonder. It shows that a backbone is not required for impressive scale, especially in water where buoyancy supports the body. The ocean allows soft animals to grow in ways that land would not easily permit. Gravity would make such a body difficult to manage on shore, but in the deep sea, it can float, flex, and extend. The giant squid proves that size has more than one blueprint. Some giants are built from bone. Others are built from muscle, water, and astonishing softness. Only the colossal squid may outweigh them among living invertebrates. The contest between these two animals is easy to misunderstand. Giant squid are famous for length, especially because of their long feeding tentacles. Colossal squid, by contrast, are generally heavier and more robust, with a thicker body and massive arms. So the question of which is bigger depends on what kind of size we mean. One may stretch farther. The other may carry more mass. This distinction matters because it prevents the two animals from blurring into one imagined super squid. Each is impressive in a different way, shaped by its own habitat and hunting style. The colossal squid is strongly associated with colder southern waters and a more heavily built form. The giant squid is more widely known through strandings and long dramatic measurements. Together, they show that the deepest parts of the ocean have produced more than one kind of living giant. Giant squid and colossal squid are different animals entirely. The names sound like variations on the same idea, but the animals are not interchangeable. They belong to separate scientific groups, and their bodies reveal different evolutionary solutions. Giant squid are long and slender, with feeding tentacles that contribute greatly to total length. Colossal squid are bulkier, heavier, and built with a different armament. Their habitats also differ, with colossal squid especially linked to Antarctic and subantarctic waters. Confusing them is understandable, because both are enormous, elusive, and tied to deep-sea mystery. Yet separating them makes both more interesting. It means the ocean has not produced one single giant squid type. It has produced multiple large cephalopods with different designs and lives. The distinction also helps science stay precise. Legends may merge sea monsters together, but biology reveals separate lineages, separate adaptations, and separate stories moving through the dark water. Colossal squid have hooks, while giant squid rely on toothed suckers. This is one of the clearest differences between the two famous giants. The colossal squid has swiveling hooks on parts of its arms and tentacles, which gives it a more visibly weaponized grip. The giant squid uses toothed sucker rings instead, creating a hold based on suction and serrated edges rather than hooks. Both systems are formidable, but they work in different ways. Hooks can snag and anchor into prey. Toothed suckers can clamp, scrape, and leave circular marks. These details matter because they show how similar predators can evolve different tools for the same problem. In dark water, catching a struggling animal is difficult. One lineage answered with hooks. Another answered with powerful suckers edged like tiny saws. The comparison feels almost like examining two deep-sea inventions side by side, each one shaped by hunger, struggle, and millions of years of trial. Giant squid roam many oceans, not just one legendary sea. Their story does not belong to a single coastline or mythic patch of water. Evidence has come from widely separated parts of the world, which suggests a far broader distribution than old legends might imply. This animal is not a local monster haunting one sailor's map. It is a deep ocean inhabitant with a range that crosses basins and climates. That wide spread makes sense for a creature tied to deep water, where the boundaries that matter are not national borders or surface landmarks. Depth, temperature, currents, prey, and continental slopes may shape its world more than anything visible from above. The idea is thrilling because it means the giant squid is both rare to us and widespread in reality. It may pass through waters near many lands, unseen beneath ships, storms, fishing grounds, and moonlit surfaces. living an international life in darkness. They have been found near New Zealand, Japan, Spain, and Newfoundland. These places sound far apart because they are, yet each has contributed to the record of this elusive animal. Some regions are famous for strandings. Others are linked to observations, fisheries, or specimens recovered from predators. Together, they show how global the story really is. New Zealand waters have offered important cephalopod discoveries. Japan helped transform underwater observation. Spain and Newfoundland have both played roles in the history of specimens coming ashore. When you place these locations on a map, the pattern becomes more astonishing than any single sighting. The giant squid is not confined to one haunted trench. It appears along the edges of continents and islands where deep water rises close enough for evidence to reach human hands. Each place becomes a meeting point between two worlds. Above is the familiar coast. Below is a hidden realm where one of Earth's strangest animals may be passing through. Their range likely follows deep water and rich hunting grounds. A giant squid does not wander randomly through the sea. Like other predators, it must live where food and suitable conditions overlap. Deep continental slopes, submarine canyons, and productive ocean regions may all create the right mix of prey, depth, and cover. These areas can concentrate life by moving nutrients through the water and supporting food webs that extend far below the surface. For the squid, such places offer opportunity. Smaller squid, deep-sea fish, and other animals may gather or migrate through these zones, creating hunting possibilities in an otherwise vast environment. This helps explain why evidence often appears near places where deep water lies close to land. The animal's world is not the flat blue surface we see from a boat. It is a landscape of underwater cliffs, slopes, currents, and feeding corridors, and somewhere within that hidden geography, the giant squid finds its path. Giant squid are rarely seen because they avoid shallow water. The reason this animal feels so legendary is not only that it is strange. It lives beyond the places where people usually look. Shallow seas are full of nets, divers, boats, reefs, and coastal light. A giant squid belongs farther down, in water where pressure rises and the surface world becomes irrelevant. That choice of habitat shields it from ordinary observation. Even when research vessels pass above, the animal may be hundreds of meters below, moving through a huge, dark volume with no reason to come upward. This makes every sighting feel like an accident of geography or timing. Humans are land animals who visit the sea from above. The giant squid inhabits a layer we cannot enter easily, and it has no need to meet us there. Its rarity is not just mystery. It is distance, depth, and a life lived outside our normal reach. Their bodies become fragile after death at the surface. A living giant squid is supported by the water around it. Its tissues are soft, flexible, and suited to a suspended life in the deep. Once it dies and rises or washes ashore, that support is gone. Gravity, waves, sunlight, bacteria, and handling can quickly change the body. Skin loosens. Arms tear. The mantle collapses. A creature that once moved with purpose can become shapeless and difficult to interpret. This is why fresh specimens are so valuable. Scientists must act quickly to measure, photograph, preserve, and sample them before the evidence fades. It also explains why old reports could be confusing. People were not always seeing the animal as it had lived. They were seeing the remains of a deep-sea body after it had been transformed by the surface world. Even in death, the giant squid reminds us that it belongs somewhere else. Dead specimens can look distorted from pressure and decay. When a deep ocean animal reaches human hands, it has already crossed a boundary its body was never meant to cross. the pressure around it has changed dramatically. Its tissues may have expanded, softened, or torn. Decay begins to alter shape, color, and texture. A tentacle may appear longer than it was in life. The skin can lose its natural tone. The eyes may collapse or cloud, making the animal look more monstrous than biological. This distortion matters because it shapes public imagination. Many people first met the giant squid through photographs of stranded remains, not through images of a living animal in its own world. Those remains are scientifically useful, but they are also imperfect translations. They show the evidence of an extraordinary creature, while hiding its living grace. To understand it properly, we have to imagine the body restored to cold darkness and buoyant water. Old length claims were often exaggerated by stretched tentacles. In the early days of giant squid reports, measuring was not always careful or consistent. A stranded animal might be pulled along a beach, handled by crowds, or measured after its long tentacles had become elastic and damaged. Because those tentacles can stretch after death, a real specimen could produce a measurement that made the animal seem even more enormous than it had been in life. This helped fuel dramatic claims that traveled through newspapers, stories, and scientific debate. The problem was not always dishonesty. Sometimes it was simply the difficulty of measuring a soft creature that had already begun to change. A few extra feet could become part of the legend. Modern researchers treat total length with caution for this reason. The animal is genuinely remarkable, but the most reliable measurements must separate living biology from the misleading effects of death, stretching, and excitement. Modern scientists measure relaxed bodies to avoid sea monster mistakes. Today, researchers are much more careful about how size is recorded. They look at mantle length, arm length, tentacle condition, and whether the tissues have been pulled or damaged. A relaxed measurement is more useful than a stretched one because it reflects the animal's real proportions more accurately. This careful approach may sound less dramatic, but it actually makes the science more powerful. It allows comparisons between specimens from different oceans and different times. It helps separate one species from another. It also prevents old folklore from creeping into modern data. The goal is not to make the giant squid smaller in our imagination. The goal is to see it clearly. When scientists measure with restraint, the result is a creature that remains astonishing without becoming impossible. In a way, accuracy gives the animal back its true grandeur, free from both exaggeration and disbelief. Their true size is impressive without any exaggeration. Even when the wildest claims are removed, the animal still stretches the imagination. A large individual can extend across a room, reach beyond a car, or match the length of familiar vehicles when its arms and tentacles are included. The body is not a bulky tank of muscle, but the total living outline is immense. That is what makes the truth so satisfying. We do not need tales of impossible monsters to feel wonder. The real creature is already one of the longest animals alive, with a form unlike anything most people will ever see directly. Its scale also changes how we think about the deep ocean. This is not a world filled only with tiny drifting lights and delicate animals. It can support predators of breathtaking reach. The measured, verified giant squid is not a disappointment after the legends. It is the reason the legends had power. Giant squid may live only a few years. For an animal that can grow so large, its life may be surprisingly brief. Evidence from growth structures suggests that giant squid do not spend decades slowly becoming enormous. Instead, they may race through life, growing rapidly, reproducing, and dying within a relatively short span. That possibility makes the animal feel even stranger. Its size is not the result of ancient age. It is the result of intense biological speed. Somewhere in the deep, a young squid may be turning food into tissue at a remarkable rate, expanding into one of the ocean's great shapes in just a few seasons. This kind of life history is common among many cephalopods. They burn brightly, grow fast, and leave the next generation behind. The giant squid may seem timeless because it belongs to legend, but the individual animal may be a brief visitor, passing quickly through darkness. Their fast growth may turn tiny hatchlings into ocean giants. The transformation from a tiny young squid to a large adult is one of the most astonishing parts of its biology. To grow so quickly, the animal must feed efficiently and convert energy into body tissue with remarkable urgency. This rapid rise through size classes may be a survival strategy. Small young animals are vulnerable to many predators, while larger bodies open new hunting possibilities and reduce some risks. Growth is not just getting bigger. It is moving through different roles in the ocean. The young squid begins as part of the drifting food web, then gradually becomes a stronger hunter with expanding reach and deeper habits. In a few years, it may go from near invisibility to a creature capable of battling for survival with some of the sea's most powerful predators. That scale of change makes its life feel like a hidden race against time. A baby giant squid begins life almost invisibly small. It is hard to reconcile the adult animal with its beginning. The hatchling does not enter the sea as a miniature monster. It begins as a tiny creature, delicate enough to be lost among plankton and drifting particles. At that stage, it is part of a vast living cloud of young animals, eggs, larvae, and microscopic food. Many predators would see it as a meal rather than a future giant. Its survival depends on growth, luck, and the ability to pass through dangerous early stages. This contrast is one of nature's great surprises. The same life that may one day stretch through deep water with enormous eyes and reaching tentacles starts as something almost impossible to notice. Every adult giant squid is therefore a survivor of an unseen childhood, a creature that escaped countless mouths before becoming one of the most mysterious hunters in the ocean. Young giant squid drift in shallower layers before descending deeper. The early life of the animal may unfold in waters closer to the surface than the adult's usual realm. This makes sense for many marine species, because upper layers can offer warmer temperatures, more food, and currents that carry young animals across wide distances. As the squid grows, its body and behavior change, allowing it to enter deeper, colder, darker zones. That descent is not simply a movement downward. It is a shift into another world. The young animal leaves the brighter, more crowded layers and begins to inhabit the dim ocean where its adult adaptations become useful. This journey may also help explain how giant squid spread across large regions. Currents could carry early stages far from where they hatched. Later, the survivors sink into deeper habitats and join the hidden population below. Their lives may begin in drifting light, then continue in darkness. Scientists still know very little about their nurseries. One of the most important places in any animal's life is also one of the least understood here. A nursery is where young animals begin feeding, growing, and avoiding danger. For giant squid, those places remain difficult to identify because eggs and young are rarely found with certainty. Researchers can infer possibilities from ocean currents, juvenile specimens, and adult distribution, but the full picture remains incomplete. This matters because the nursery stage may shape everything that follows. It influences survival rates, population connections, and how the species responds to changes in the ocean. Imagine trying to understand a forest while never seeing seeds sprout. That is close to the challenge scientists face. The adult animal is mysterious enough, but the beginning of its life is even more hidden. Somewhere in the sea, tiny squid are growing into giants, and we still barely know where. Giant squid eggs have rarely been observed by humans. For such a famous animal, its earliest stage remains almost unknown. Eggs are the starting point of the next generation, yet direct observations are scarce and uncertain. In the open ocean, eggs may be released in gelatinous masses, carried by currents, or scattered in ways that make them extremely hard to find. They are also vulnerable to being eaten, damaged, or mistaken for the eggs of other squid. This absence of evidence leaves a large blank space in the animal's story. We know the adult from strandings and rare images. We know it has to reproduce somewhere. But the actual beginning, the quiet moment when new life forms inside drifting eggs, remains mostly beyond observation. That mystery is deeply humbling. One of the ocean's most famous creatures may begin in a form that passes beneath ships and satellites unnoticed, hidden among countless other fragile lives. Their reproductive lives remain one of marine biology's mysteries. Finding a mate in the deep ocean is a challenge almost impossible to imagine. The water is vast, light is limited, and adults may be widely scattered. Yet reproduction happens, or the species would vanish. Scientists study anatomy, mature specimens, and related squid to piece together how the process may work, but many details remain uncertain. How often do adults encounter one another? What signals guide them? Do they gather in certain places, or meet by chance along feeding routes? These questions are not small details. They shape our understanding of the entire species. Reproduction is the bridge between generations, and for giant squid, that bridge is still wrapped in darkness. The mystery is not just romantic or strange. It is scientifically crucial. To understand how the animal persists across oceans, we must understand how two rare deep-sea lives find each other in the first place. Males use a specialized arm or organ to transfer sperm. In many cephalopods, reproduction involves specialized structures rather than ordinary mating in the familiar mammalian sense. Male giant squid possess adaptations that allow sperm packets to be delivered to the female. The exact details can be difficult to interpret because living behavior is rarely seen, but preserved anatomy shows that the process is highly specialized. This is biology shaped by a difficult environment. In deep water, a reproductive encounter may be brief and rare, so the transfer system must work efficiently when the chance appears. Sperm packets can remain associated with the female until eggs are released or fertilized, depending on the mechanism involved. It is a strange and intricate solution, and it reminds us that the giant squid's hidden life is not only about hunting and evading whales. It also includes delicate reproductive engineering, designed to continue a lineage that humans almost never witness alive. Females may release enormous numbers of eggs into the sea. Producing many eggs is a common strategy in the ocean, where early life can be perilous. Most young animals will not survive, so abundance becomes a kind of insurance. The female giant squid may invest in large numbers of eggs, giving at least some offspring a chance to pass through the dangerous beginning stages. This approach is very different from the strategy of mammals that raise a few young with extended care. In the open sea, the next generation may be left to currents, food availability, and luck. That sounds harsh, but it has worked for countless marine species across immense spans of time. The image is powerful. Somewhere in the dark water, a large female releases the future in tiny forms, each one carrying the potential to become a giant. Most will vanish into the food web. A few may grow into legends. Their young must survive a world full of predators. The ocean is especially dangerous for small animals. Fish, jellyfish, crustaceans, squid, and many other hunters feed on tiny drifting life. A young giant squid does not begin at the top of the food chain. It begins as prey. Its early survival depends on avoiding detection, finding food, and growing quickly enough to escape the most vulnerable stage. This gives its life story a dramatic reversal. The animal that may later seize prey with long tentacles must first survive being hunted by much smaller predators. Every adult is evidence of a long sequence of escapes. It avoided being eaten when it was tiny. It found enough food as it grew. It entered deeper layers without disappearing. That history is invisible where we look at an adult specimen, but it is written into its existence. Before it became a giant of the deep, it was a fragile survivor. Adult giant squid are hunted mainly by sperm whales. At adult size, few predators are known to take them regularly, but sperm whales are the great exception. These whales are built for deep diving and can reach the squid's world in search of food. The relationship between the two animals is one of the ocean's most famous predator-prey connections. It links a breathing mammal from the surface to a soft-bodied cephalopod of the depths. The whale must descend, search, capture, and return to air. The squid must detect, evade, or resist a hunter with powerful jaws and immense diving ability. This encounter reveals how connected the ocean's layers are. A whale seen calmly at the surface may soon be hunting in darkness far below. A squid hidden from human eyes may become part of a whale's energy budget. Their lives meet in a vertical drama that joins sunlight, air, pressure, and darkness. Sperm whales dive into darkness to find giant squid. A sperm whale's hunt begins at the surface, with a breath. Then the animal tips downward and leaves the bright ocean behind. As it descends, pressure builds and light fades, but the whale is adapted for the journey. It can hold its breath for long periods and use sound to search where vision fails. Far below, it enters the realm where large squid may live and feed. The hunt is not a simple chase across an open plain. It is a search through a dark, three-dimensional space, guided by echoes and experience. This makes the whale one of the few animals capable of regularly reaching adult giant squid. The idea is breathtaking. One air-breathing giant dives from above, while one soft-bodied giant moves below. Their meeting point lies in the black middle of the ocean, beyond ordinary sight, where both animals become specialists. Whale stomachs have revealed many giant squid beaks. Some of the strongest evidence for this predator-prey relationship has come from inside sperm whales themselves. Soft squid tissue digests relatively quickly, but the beak is tough and persistent. When researchers examine stomach contents, they may find collections of beaks that record previous meals. These remains can identify squid species and sometimes suggest the size of the animals eaten. It is an unusual way to study a creature that avoids direct observation. Instead of watching every hunt, scientists read the leftovers. A whale becomes, in a sense, an archive of deep-sea feeding. This method has revealed that giant squid are not just occasional legends in a whale's life. They can be part of a real diet in certain regions. The beaks are small compared with the animals they represent, but they open a window into hidden hunting grounds that humans rarely see. Squid beaks resist digestion long after soft bodies disappear. The beak is made of tough material that survives conditions that quickly erase muscle and skin. Inside a predator's stomach, the soft body of a squid may vanish, but the beak can remain as a durable clue. This is why it has become so important to marine science. A single beak can carry information about identity, size, and feeding ecology. Its shape can be compared with reference collections, allowing researchers to connect a stomach sample to a species that may otherwise never be seen. There is something almost poetic about that. The giant squid is famous for being elusive, yet one of its smallest hard parts keeps speaking after the rest is gone. From these dark, curved fragments, scientists reconstruct meals, estimate populations, and map invisible relationships. The beak is not just a mouthpart. It is evidence with a long afterlife. Scientists can estimate squid size from recovered beaks. A beak may seem too small to stand in for an entire giant squid, yet it can carry remarkable information. Researchers compare the shape and measurements of recovered beaks with those from known specimens. From those relationships, they can estimate the size of the animal that once carried it. This is especially useful because many giant squid are never found whole. A whale may digest the soft body and leave only the hard mouthparts behind. A net may bring up fragments instead of a complete animal. In those cases, the beak becomes a measuring key. It lets scientists turn a dark, curved remnant into an educated picture of length and mass. The process is not magic. It is careful comparison, built from anatomy and statistics. Still, there is wonder in it. From one small piece, science can sketch the outline of a creature that vanished in the deep. Giant squid beaks helped prove the legends had living roots. For a long time, huge sea creatures belonged more comfortably to rumor than to science. Stories could be dismissed as exaggerations, especially when they came from frightened sailors or strange objects found after storms. Beaks changed that conversation. They were physical, durable, and unlike ordinary fish bones. When naturalists examined these hard parts, they realized they came from real cephalopods of extraordinary size. A legend could be questioned, but a specimen could be measured. That is why these remains mattered so much. They formed a bridge between folklore and biology. People had imagined monsters in the sea, and while many tales were surely embroidered, the ocean truly did contain an enormous squid. The beak became a kind of proof that wonder and evidence can meet. It showed that not every old story is true, but sometimes a real animal waits behind the myth. Some whale skin shows circular scars from giant squid suckers. A sperm whale's body can carry marks from encounters far below the surface. These scars are often round because they match the gripping structures on squid arms and tentacles. The pattern is what makes them so intriguing. A single mark might be explained in many ways, but repeated circles across the skin suggest contact with a creature that held on with many suckers at once. These traces turn the whale into a living record of deep ocean contact. We do not see the moment clearly. We see the aftermath on a body that returns to the surface to breathe. The scars also reveal scale. A predator powerful enough to hunt giant squid can still be marked by them. That does not make the squid the winner of these encounters, but it does make it an active participant. It grips, resists, and leaves evidence behind. These scars can widen as a whale grows older. A mark made on a younger whale does not remain frozen at its first size. As the animal's body grows, the skin expands, and old circular scars can stretch wider over time. This means a very large scar on an adult whale may not perfectly match the original size of the sucker that made it. That detail matters because it prevents mistaken claims about impossible squid proportions. It also adds a sense of biography to the whale's skin. Some scars may be recent. Others may be memories carried from earlier years, changed by growth and time. A whale can become a moving archive of past hunts, with marks from different stages of life spread across its body. Each scar began as a moment of contact in the dark. Years later, it may still travel through the ocean, widened by the whale's own life story. The battles between whales and giant squid happen unseen. This is one of the great dramas of the natural world, yet almost no one has witnessed it directly. A whale leaves the surface, dives into darkness, and searches by sound. Somewhere below, a squid senses movement pressure, or disturbance. Then, in a cold space beyond human sight, the encounter begins. We know pieces of the story from stomach contents, scars, and the biology of both animals. But the full sequence remains largely hidden. Does the squid flee first? Does it grip the whale's head? How long do these encounters last? How often does the squid escape? These questions make the relationship feel even more powerful. It is not a spectacle arranged for us. It is a private struggle of the deep ocean, carried out in pressure and darkness. Science can reconstruct the edges, but the center remains beautifully unknown. Giant squid may use darkness itself as their best defense. Some animals defend themselves with shells, spines, venom, or speed. For a giant squid, the environment may be part of the protection. In deep water, visibility is limited. Distances are difficult to judge, and shapes can vanish quickly. A long, soft body can become hard to track when there are few clear reference points. The squid's reddish tones may also fade into the low-light background, because red wavelengths disappear quickly with depth. The result is not invisibility in a magical sense. It is practical concealment. The animal lives in a place where light itself fails, and that failure can help it survive. A predator may rely on sound, motion, or bioluminescent clues, but the squid still benefits from being hard to see directly. Darkness is not empty around it. Darkness is cover, habitat, and shield. They probably avoid noisy machines better than scientists expected. Studying a giant squid is difficult partly because human equipment changes the environment it enters. Submersibles, camera frames, lights, engines, cables, and remotely operated vehicles can all create sounds or disturbances. An animal adapted to subtle cues in the deep may notice these intrusions before it comes close. That could explain why traditional filming attempts often failed. The squid may not have been absent. It may have been avoiding the strange presence. This possibility changed research strategy. Instead of charging into the deep with bright lights and loud machinery, scientists began thinking more like patient observers. They looked for quieter systems, dimmer illumination, and lures that worked with deep-sea behavior rather than against it. The lesson is humbling. Sometimes the mystery is not that an animal cannot be found. Sometimes it is that our own methods announce us too loudly. Red light helped researchers film them without scaring them away. Many deep-sea animals are less sensitive to red light because red wavelengths do not travel far in seawater. That makes red illumination useful for observation. It can allow cameras to see while remaining less obvious to creatures living in the depths. For giant squid research, this mattered enormously. Bright white light could startle or repel animals accustomed to dim conditions. Red light offered a way to reduce the disturbance and let the deep behave more naturally. It is a beautiful example of science succeeding by becoming less intrusive. Instead of forcing the hidden world to reveal itself under harsh glare, researchers adjusted their tools to match the animal's reality. The result was not just better footage. It was a change in attitude. To see a giant squid alive, humans had to stop lighting the deep like a stage and start listening to its rules. A glowing lure once tempted a giant squid toward a camera. In the deep sea, light can be a message. Many animals glow to attract prey, confuse predators, or communicate in darkness. Researchers used that principle by creating a lure that gave off a controlled bioluminescent display. It was designed to resemble the kind of light a struggling or interesting deep-sea creature might produce. Instead of chasing the squid, the camera waited while the lure invited curiosity. That strategy helped bring one of the ocean's most elusive animals into view. The moment was thrilling because it depended on understanding the deep as a language of signals. The lure did not shout. it whispered in light. Somewhere in the black water, a giant squid noticed and approached. In that instant, technology borrowed a trick from nature, and the hidden animal answered. The result was a rare meeting between human patience and deep-sea instinct. The lure imitated deep-sea signals that predators might investigate. The idea behind the glowing bait was not random brightness. It was inspired by a defensive display produced by some jellyfish when they are under attack. That display can attract a larger predator toward the attacker, creating confusion or danger for the original hunter. Scientists realized that such a signal might interest animals looking for food or opportunity in the dark. By copying the pattern, they created something a giant squid might find worth approaching. This is fascinating because it shows how research can turn ecology into design. A signal that evolved in one animal became a tool for studying another. The deep sea is full of such hidden conversations, where light carries warnings, invitations, and traps. Humans usually miss the meaning. In this case, researchers learned enough of the language to ask a question, and the giant squid came close enough to answer. The first deep-sea footage changed how scientists imagined their behavior. Before living footage existed, the animal was often pictured through stranded remains and dramatic legend. It could seem monstrous, sluggish, or barely understandable. Seeing it alive in deep water changed that impression. The squid appeared controlled, responsive, and suited to its surroundings. Its movements showed that the long body and arms were not awkward accidents of anatomy. They were coordinated parts of a living system. This mattered because behavior cannot be fully understood from a dead specimen. A preserved body can reveal structure, but only a living animal reveals timing, posture, and intent. The footage gave scientists a new kind of evidence. It showed the giant squid not as a ruined object on the beach, and not as a fantasy from old stories, but as a functioning predator in its own habitat. That shift made the creature feel more real and more mysterious at once. A filmed giant squid moved with calm, deliberate precision. The most surprising thing about rare footage is not always the size. It is the composure. The animal does not need to thrash wildly to be impressive. In its own world, it can hover, orient, extend, and adjust with remarkable control. The arms seem to explore space. The body changes angle. The whole creature responds as if measuring the situation. That deliberate quality challenges the idea of the giant squid as a mindless monster. It looks more like an animal making choices moment by moment. Of course, we must be careful not to read human thoughts into it. But behavior can still reveal competence. A deep-sea predator that wastes energy would not survive well. Its motion must be efficient, tuned, and purposeful. Watching it move slowly can be more astonishing than watching it rush, because control in darkness is its own kind of power. Their arms can appear to bloom around prey. When a squid brings its limbs forward, the shape can change dramatically. Arms that once trailed in a long arrangement can spread, curl, and surround the target with startling beauty. The motion can look almost floral, but its purpose is entirely practical. Multiple arms create more contact points, more control, and fewer escape routes. Once prey is within the arm crown, the animal can guide it toward the mouth with coordinated pressure. This surrounding movement is part of what makes cephalopods so unlike fish. A fish often bites with a front-facing jaw. A squid can envelop, hold, and reposition with a flexible ring of living tools. The visual effect is unforgettable because it transforms the animal's silhouette in an instant. One moment it is a long, pale form in darkness. The next, its arms open around the center of action, like a trap closing softly. Giant squid may be ambush predators rather than constant chasers. The deep sea is not a place where energy can be wasted carelessly. Food may be scattered, and long pursuits can be costly. For this reason, the giant squid may rely more on waiting, positioning, and sudden strikes than on chasing prey over long distances. Its body supports that idea. Long tentacles extend reach. Large eyes detect movement. Soft coloration helps reduce visibility. Jet propulsion can provide bursts when needed, but constant high-speed pursuit may not be its usual style. An ambush strategy would fit a world where patience pays. The animal can drift or hover until something comes within range, then turn stillness into action. This does not make it passive. It makes it efficient. The giant squid may be less like a racing hunter and more like a living trap in the water column, saving its speed for the exact moment it matters. Their soft bodies leave almost no fossil record. Fossils favor hard parts. Bones, shells, teeth, and mineralized structures can survive long after soft tissue disappears. A giant squid is mostly soft-bodied, so its chances of fossilization are very poor. When it dies, the body is usually eaten, decayed, or destroyed before burial can preserve it. This creates a huge problem for anyone trying to trace its ancient history. The absence of fossils does not mean these animals had no past. It means their past is difficult to capture in stone. Imagine trying to reconstruct a library after nearly every page has dissolved. Scientists must rely on rare hard parts, comparisons with living relatives, and genetic clues to infer the larger story. The fossil silence is part of the mystery. A lineage can be ancient and important, yet leave only faint traces behind, because softness does not easily become memory in rock. Ancient giant squid relatives are mostly known from hard mouthparts. When soft bodies vanish, the toughest pieces become the storytellers. In cephalopods, beaks and related hard structures can sometimes preserve or be recognized when the rest is gone. These fragments may not look dramatic to a casual observer, but to specialists they can suggest relationships, feeding styles, and evolutionary history. A hard mouthpart can reveal that a squid-like animal existed where no full body remains. This is a very different kind of paleontology from studying dinosaur skeletons. There may be no towering frame to assemble, no complete outline to display. Instead, the evidence can be small, dark, and technical. Yet it matters profoundly. It tells us that ancient oceans held cephalopod hunters whose soft forms usually disappeared without trace. The giant squid's family history is therefore not written in grand bones. It is written in fragments that survived because they were hard enough to resist oblivion. Their evolutionary story is hidden in scattered anatomical clues. To understand where giant squid came from, scientists must combine many kinds of evidence. Modern anatomy shows how their organs, arms, eyes, and feeding structures compare with other cephalopods. Genetic data offers another path, revealing relationships that body shape alone can obscure. Rare preserved parts add clues from the past, while living relatives show possible patterns of behavior and development. No single clue is enough. The story has to be assembled like a map made from islands. This makes the animal's evolution feel especially intriguing. Its history is not displayed in a neat sequence of fossils. It is inferred from anatomy, molecules, and careful comparison. The result is a lineage that seems both familiar and hidden. We can place the giant squid within cephalopod evolution, but many details remain unresolved. Its past, like its present life, is partly concealed by the ocean's depth and time. Cephalopods have existed for hundreds of millions of years. The giant squid is part of an ancient animal tradition that reaches far beyond human history, beyond mammals and beyond dinosaurs. Early cephalopods appeared in ancient seas when life on land was still limited. Many carried shells and moved through oceans that would look alien to us now. Over time, the group produced nautiloids, ammonites, belemnites, octopuses, cuttlefish, and squid. Some lineages vanished completely. Others transformed into the flexible, intelligent animals we know today. This deep ancestry makes the giant squid feel less like an isolated oddity and more like the latest expression of a very old experiment. The ocean has been shaping cephalopods through mass extinctions, climate shifts, changing predators, and new habitats for immense stretches of time. When we imagine a giant squid moving through darkness, we are seeing a living branch of a story that began in seas unimaginably ancient. Giant squid inherited a deep legacy of ocean intelligence. Cephalopod intelligence is not identical to human intelligence, which makes it even more fascinating. It evolved along a separate path, in animals with arms, beaks, soft bodies, and nervous systems, unlike ours. Octopuses solve puzzles and explore with astonishing flexibility. Cuttlefish use complex camouflage and show signs of learning. Squid coordinate movement, hunting, and visual signals in ways that reveal impressive sensory control. The giant squid belongs to this broader tradition, even though its own mind is much harder to study. We cannot easily place it in a laboratory or watch its daily choices. Still, its lineage suggests a nervous system capable of processing a demanding world. Deep-sea life requires decisions about prey, predators, movement, and energy. The legacy it carries is not a human-like mind. It is something older, stranger, and shaped by water, darkness, and the many-armed possibilities of cephalopod evolution. Their nervous systems are complex, but their minds remain mysterious. Anatomy tells us that giant squid are not simple animals. They have large eyes, coordinated limbs, rapid movement systems, and a nervous organization inherited from active cephalopod ancestors. Yet complexity does not automatically reveal experience. We still do not know how they perceive their world from moment to moment, how they learn, or whether individuals behave differently from one another. The difficulty is access. Most animals studied for cognition can be observed repeatedly. Giant squid appear briefly, if at all. Their minds must be inferred from structure, related species, and rare behavior. That uncertainty is not a failure of science. It is part of the frontier. The animal sips at a boundary between what we can measure and what we can only carefully imagine. Somewhere in the deep, a complex nervous system is reading signals we barely understand, inside a creature we have barely met. Giant squid may sense vibrations moving through the water. In the deep ocean, touch does not end at the skin. Water carries pressure waves, disturbances, and movements across distance, and many marine animals can read those signals in ways humans barely notice. A giant squid may detect changes created by prey, predators, currents, or approaching objects. Its arms and body are covered in sensitive tissues that help it respond to contact and motion. This ability would be especially valuable where vision is limited and sound behaves differently than it does in air. A fish flicking its tail, a whale passing through the dark, or a machine descending from above could all create patterns in the water. To the squid, the ocean may not feel empty at all. It may feel alive with subtle tremors. Each vibration could be a clue, a warning, or an invitation to turn toward food. Their world is shaped by pressure, silence, and faint light. The place they inhabit would feel almost impossible to us. Pressure increases with depth until the water presses from every direction with enormous force. Sunlight fades into a dim blue remnant, then gives way to darkness broken only by living flashes. Sound travels far, yet the world can still seem vast, and still because there are no birds, waves, or familiar surface noises. In this setting, every sense must be tuned to scarcity. Movement has to be efficient. Signals must be noticed quickly. A faint glow can matter as much as a bright lamp would on land. The giant squid is not merely surviving in this environment. Its body has been shaped by it. The cold, the weight of water, and the lack of easy light are not background details. They are the forces that helped make the animal what it is. They live far below the reach of ordinary divers. A human diver can only go so far before pressure, darkness, cold, and breathing limits become serious barriers. The giant squid's usual world lies beyond that human threshold. Reaching it requires submersibles, remotely operated vehicles, specialized cameras, or evidence brought upward by chance. This distance explains why the animal remained so difficult to study for so long. It was not hiding behind a reef where a patient diver could wait. It was living in a zone that human bodies are simply not built to visit unaided. That gives every observation a sense of expedition. To see one alive, technology has to act as our borrowed body, carrying eyes and sensors into a place where lungs and bones cannot comfortably follow. The animal's habitat reminds us that birth still contains frontiers, as inaccessible as mountains on another planet. Deep-sea pressure helps support their soft, floating bodies. A giant squid is not built like a land animal fighting gravity. Its body is made for suspension in water, where buoyancy carries much of the load. In the depths, pressure surrounds it evenly, and the sea itself becomes part of the support system. That helps explain why its soft tissues can function so well without a skeleton like ours. The body can flex, expand, contract, and glide through the water without needing heavy bones to hold it up. At the surface, we often see dead specimens distorted by gravity and air exposure. That view can mislead us. In the deep, the animal's softness is not a weakness. It is part of a design suited to floating, reaching, and moving within a dense liquid world. The squid belongs to water so completely that removing it from that support changes the meaning of its shape. At the surface, their tissues can collapse and suffer damage. When a giant squid reaches shallow water or land, its body enters conditions that do not suit it. The pressure is lower. The temperature may be different. Waves, rocks, and handling can damage delicate tissue. A form that worked beautifully in the deep can quickly look broken, deflated, or unnatural. This is why stranded specimens may seem grotesque or confusing. They are not showing the animal as it lived. They are showing what happens when a deep-sea body is pulled into the surface world. Scientists have to interpret such remains with care, separating useful evidence from changes caused after death. This also gives living footage special value because it shows posture and movement that a body on a beach cannot preserve. The surface can deliver the giant squid to us, but it cannot truly represent the creature's life. Giant squid are rarely kept intact without careful preservation. A complete specimen is a scientific treasure, but keeping it whole is difficult. Soft tissues decay quickly, and a large body is not easy to store, move, or protect. Researchers must preserve the animal before bacteria and damage erase important details. That process can involve special fluids, controlled containers, and careful handling of arms, eyes, mantle, and internal organs. Without that work, the specimen may lose the very features that make it valuable. A preserved giant squid allows scientists to return again and again to the same evidence. They can examine anatomy, compare measurements, study tissue, and teach the public what deep-sea life can become. Preservation turns a fleeting stranding into a lasting record. It is one of the ways humans hold onto an animal that otherwise appears briefly, changes fast, and disappears back into mystery. Museums preserve them in tanks of special fluid. To display or study a giant squid for years, a museum cannot simply dry it or mount it like a skeleton. The animal has no large bony frame to hold the familiar shape. Instead, it is often preserved in liquid, inside a tank big enough to support its long body and protect delicate tissues. These tanks can become attractions in their own right. Visitors look through glass at an animal that once lived in a place almost no human can visit. The fluid slows decay and keeps the specimen available for research, but it also creates a strange stillness. The squid appears suspended between life and legend, no longer moving, yet still carrying the reality of the deep into public view. In that tank, the hidden ocean becomes present. People can stand close to something that once seemed like rumor. Some preserved specimens are long enough to fill entire galleries. A giant squid does not fit easily into ordinary museum space. Its arms and tentacles can stretch across display areas, forcing curators to think carefully about tanks, layout, lighting, and visitor perspective. Seeing one at full length changes the experience completely. A photograph may suggest size, but standing beside the body gives scale of physical meaning. The eye travels from the mantle to the arms, then along the tentacles, and the animal seems to keep going. This public encounter is powerful because it makes the deep sea feel less abstract. The creature is not a distant statistic or a sailor's exaggeration. It has length, structure, texture, and presence. In a gallery, the giant squid becomes both scientific specimen and ambassador from a hidden world. Its preserved body turns an inaccessible life into something people can meet face to face. Public displays turned a hidden deep-sea animal into a global icon. Most people will never see a living giant squid, yet millions know its name. Museums, documentaries, illustrations, and rare footage help transform it from obscure specimen into one of the most recognizable deep-sea animals. Public display played a major role in that transformation. When people saw the body, they no longer had to imagine only a monster from stories. They could see arms, suckers, eyes, mantle, and beak as parts of a real animal. That shift matters. It turns fear into curiosity. It turns legend into biology. A specimen behind glass can inspire children, artists, scientists, and anyone who wonders what else the ocean holds. The giant squid became famous because it sits at a perfect intersection. It is real enough to study, strange enough to astonish, and hidden enough to keep the imagination alive. The giant squid helped inspire the legend of the kraken. The kraken belongs to Northern Sea folklore, where it was imagined as a vast creature capable of disturbing ships and terrifying sailors. The giant squid cannot sink vessels in the way old tales described, but it likely helped give those tales a believable shape. A huge body seen at the surface, a tentacle caught in gear, or a decaying specimen on shore could have fed stories that grew with every retelling. The ocean has always encouraged exaggeration because so much of it is hidden. Yet the most interesting part is not that people imagined too much. It is that they were responding to something real. Beneath the myth was an animal genuinely large, unfamiliar, and difficult to explain without modern science. The kraken reminds us that folklore can sometimes be a distorted echo of true encounters with nature. Early naturalists debated whether giant squid reports were real. Before good specimens and careful descriptions accumulated, many educated people had reason to doubt the reports. The ocean was full of tall tales, and enormous tentacled creatures sounded suspiciously like sailor exaggeration. Naturalists had to decide which accounts were fantasy, which were mistakes, and which deserved serious attention. That debate shows how science handles the unbelievable. It does not accept every story, but it also cannot reject evidence simply because it sounds strange. As more remains appeared, skepticism began to soften. Measurements, drawings, beaks, and preserved parts gave researchers something firmer than rumor. The giant squid moved from doubtful anecdote into scientific reality through repeated evidence. This history is a wonderful reminder that nature can exceed expectation. Sometimes the careful answer is not to dismiss the astonishing claim, but to ask what kind of evidence would make it true. 19th century strandings helped turn sea folklore into science. During the 1800s, several important strandings and recovered remains gave scientists better material to examine. These events mattered because they arrived at a time when natural history was becoming more organized and systematic. Instead of remaining only local curiosities, specimens could be described, compared, named, and discussed in scientific circles. A stranded animal on the shore could become a paper, a drawing, a museum object, and a point in a larger argument about what lived in the deep. This was a turning point in the giant squid story. Folklore had supplied wonder, but strandings supplied evidence. They allowed people to replace vague monsters with anatomy. Arms could be measured. Suckers could be examined. Beaks could be compared. The sea's rumor became a biological subject, and one of the ocean's strangest animals began to step into the light of science. Danish scientist Japetus Steenstrup, formerly named Architeuthis in 1857. Naming the animal was more than a technical act. It gave science a stable way to discuss a creature that had long drifted through rumor, fragments, and uncertain reports. Steenstrup studied available evidence and recognized that these remains belonged to an extraordinary cephalopod deserving formal classification. Once named, the giant squid could be placed into scientific conversation with greater clarity. Researchers could compare future specimens to the same reference point, rather than treating every discovery as an isolated marvel. A name does not solve every mystery, but it creates a handle for knowledge. It let scattered observations gather around a shared identity. In this case, the name also carried grandeur, because the animal truly seemed like a ruler among squid. From that moment, a creature of legend became part of taxonomy, the orderly language humans use to map the living world. Newfoundland strandings gave scientists some of their most famous specimens. The cold waters around Newfoundland became important in giant squid history because notable specimens appeared there during a period of intense scientific interest. When large squid came ashore or were found near the coast, they offered rare opportunities for study. Local people, fishermen, and naturalists all played roles in noticing, recovering, and reporting these animals. Such events helped establish that the giant squid was not a single oddity, but a real creature appearing repeatedly in the North Atlantic. The location mattered because deep water lies within reach of coastal communities, allowing hidden ocean life to occasionally cross into human awareness. Some specimens became widely discussed and helped anchor the animal in public imagination. Newfoundland, in that sense, became one of the places where the deep sea introduced itself. A remote shore could suddenly become a scientific gateway to one of the planet's most elusive animals. Japanese researchers transformed the search by photographing one underwater. For generations, the animal was known mostly through the dead and the damaged. Then researchers working near Japan achieved something extraordinary. They captured images of a giant squid alive in its natural environment. This changed the search from speculation to direct observation. The photographs showed that patient methods could succeed where many attempts had failed. They also proved that the animal could be studied in the deep without waiting for it to wash ashore. That shift was enormous. A living image carries information that a stranded body cannot. It reveals posture, color, response, and how the animal occupies space. The achievement also inspired future efforts to film and understand deep-sea life with less disturbance. Instead of treating the giant squid as a creature that only arrived by accident, researchers had found a way to meet it in its own world. A Gulf of Mexico sighting proved they could haunt American depths. The Gulf of Mexico is not always the first place people imagine when thinking of giant squid, yet evidence from there showed how widely these animals may roam. A sighting in those waters expanded public awareness of their range and reminded researchers that deep-sea habitats exist close to heavily studied regions. This is one of the fascinating truths of the ocean. Even near busy coasts, shipping lanes, energy platforms, and research activity, hidden animals can still move through darkness below. The Gulf has deep basins, rich food webs, and complex underwater terrain. It is not just warm surface water. It is also a deep habitat with room for elusive giants. The sighting carried a special kind of thrill because it brought the mystery closer to familiar shores. The giant squid was not only a creature of remote legends, it could belong to American depths too. Their DNA suggests one widespread species may circle the world. Genetic studies have raised a surprising possibility. Instead of many separate species scattered across different oceans, giant squid may be represented by a single broadly distributed species, with populations connected across immense distances. That idea is astonishing because the adults seem so rare and elusive to us. Yet the ocean can connect life in ways that maps of land do not show. Currents may carry early stages across basins. Deep habitats may form corridors that allow populations to remain genetically linked. If this picture is correct, the giant squid is not a collection of isolated local monsters. It is one global lineage, moving through the planet's deep waters. DNA gives scientists a way to see connections that eyes and nets cannot. It suggests that beneath the separate names of seas and oceans, there may be one vast biological story flowing around the world. Giant squid populations may be connected across vast ocean distances. The deep ocean does not have fences, and for drifting young animals, currents can become long-distance pathways. This means populations separated by thousands of miles may still exchange genes over time. Adults may live in particular deep regions, but their early life stages could travel far before settling into deeper habitats. That possibility changes the scale of the animal's story. A squid found near one continent may be part of a population network linked to waters far away. The connections would not be obvious from occasional strandings. They emerge through genetics, oceanography, and the study of life cycles. This also means that protecting deep-sea ecosystems requires thinking beyond local boundaries. The giant squid's world may be planetary in a very real sense. Its life is shaped by currents, depth layers, and migrations that ignore the lines humans draw across maps. The deep ocean still hides most of their everyday lives. We know dramatic pieces of the story, but the ordinary life of the animal remains mostly unseen. Where does it spend each hour? How often does it feed? Does it rest in stillness or drift with currents? How do individuals find one another? What signals matter most in daily survival? These questions are basic, yet answers are scarce because the habitat is so difficult to watch continuously. This is what makes the giant squid endlessly compelling. It is not only rare in the sense of sightings. It is rare in the sense of understanding. Science has named it, filmed it, measured it, and traced parts of its biology, but the day-to-day rhythm remains hidden. There is still a living animal behind the famous image, making choices in darkness. The deep ocean keeps that private life mostly to itself. Every giant squid sighting feels like a message from another world. Part of the wonder comes from the fact that the animal lives on Earth, yet seems to arrive from somewhere beyond ordinary experience. A glimpse on camera, a body on shore, or a preserved specimen in a museum feels like contact with a hidden planet inside our own. The giant squid carries the deep ocean with it. Its huge eyes, long tentacles, soft body, and strange history all point toward a realm most people never imagine clearly. Each encounter tells us that the familiar surface is only the beginning. Beneath it lies a vast living space filled with stories still unfolding without us. That is why the creature remains so powerful after centuries of attention. It is not just big. It is not just rare. It is a reminder that mystery is still alive, moving through the dark water, waiting beyond the reach of our light. And so, we've drifted together through the hidden world of the giant squid. We began with an animal so large it can stretch longer than a school bus, yet so elusive that science still knows it mostly through fragments, rare footage, and bodies delivered from the deep. We followed its enormous eyes into the dim ocean, where faint shadows, tiny flashes of light, and distant movements may carry meaning. We explored its arms, its tentacles, its beak, its blue blood, and the strange three-harp system that keeps it alive in cold, dark water. We wandered through its place in the ocean story too, its battles with sperm whales, its fragile young drifting through dangerous early life, its mysterious reproduction, its connection to ancient cephalopods, sea monster legends, museum galleries, and the deep questions still waiting below the waves. And perhaps that is what makes the giant squid so captivating. It reminds us that Earth still has secret rules. Beneath the moonlit surface, beneath the rolling ships and silver currents, there are lives unfolding in darkness. Soft bodies moving through pressure, huge eyes watching the faintest glow, ancient instincts guiding silent journeys through the black water. If you enjoyed this gentle journey, you're welcome to like, subscribe, or leave a thought below. It helps others find their way here too, one sleepy soul at a time. And if you happen to still be awake, another quiet exploration should be waiting for you on the screen. But for now, there is nothing else you need to do. Let your shoulders soften. Let your breathing slow. Imagine the ocean settling around you, wide and dark and calm. Imagine every thought drifting downward, becoming lighter as it goes. The mysteries can remain where they are for tonight. The deep can keep its secrets a little longer. You can rest now. Sleep well and good night.